Good morning to all. Now we are going to see transformer. Transformer is the stationary device. It is mainly used to transmitting the electric power from one place into another place. Here, it is does not changing any frequency for the electric power. Okay, so on that for applied alternating voltage is either increasing or decreasing the corresponding current in the circuit. Okay, so the transformer, it is also the two type of transformer. One is core type transformer, another one cell type transformer. So maximum for our transformer is made up in this type, core type transformer. So it is the roadside transformer, we already seen that. Okay, so the transformer, it is also divided into two types. One is a step up transformer, another one step down transformer. It is the process of main process of the transformer. Okay, so the AC current வந்து பார்த்தீங்கன்னா டைரெக்டாக நம்மளால் ஏசி பவர் பார்த்தீங்கன்னா டைரெக்டாக நம்மளால் என்ன பண்ண முடியாது, ரிசீவ் பண்ண முடியாது. ஸோ அதுக்கு டூ மெயின் ப்ராசஸ் வந்து இந்த டிரான்ஸ்ஃபார்மரை யூஸ் பண்ணி தான் வேர் டன். Okay, so that process is called that step up transformer and then step down transformer. The two process is very important. Okay, so first we are going to see that the principle and then construction. So on this principle, the principle of the transformer is mainly it is based on the mutual inductance between the two coils. Okay, so when the alternating voltage is applied in this coil, the alternating current will be changing with the time. Then the changing the magnetic flux will be producing. Okay, so it is also inducing an EMF in the secondary coil. Okay, so first coil நமக்கு என்ன ஆகுது, current will be changing with respect to time. Okay, so it is also inducing an EMF in the secondary coil. Okay, so next we see that construction. So there are two coils of the high mutual inductance wound over the same transformer core. Okay, so the core is generally laminated and it is made up of good material like silicon steel. Okay, so the coils are electrically insulated but magnetically they are linked through the transformer core. இங்க மேல இருக்குலையா, இதான் வந்து transformer core. These are the coils. Okay, so the alternating voltage is applied in this coil. So on this coil is called that primary coil. Okay, so alternating voltage is applied in this coil so this coil is called that primary coil. And then here the output power is drawn from in this coil, so this coil is called that secondary coil. Yes. Okay, so for insulation and the cooling purpose, both core and coil are kept in a suitable container and also filled with some of the medium or medium வச்சு நல்லா fill பண்ணி வச்சிருப்பாங்க. outer frame, transformer frame வந்து outer frame ல it is also filled with suitable medium. Okay, so next we are going to see that working. So here we are applied that alternating voltage. So it producing an alternating current will be moving in the coil. Okay, so the alternating current, we already know that alternating current nale, that is nothing but changing the current with respect to time. So it is also inducing an magnetic flux. The magnetic flux also changing. So the magnetic flux will be changing. It is producing an induced EMF in the secondary coil. If there is no magnetic flux leakage, means the whole magnetic flux linked with the primary coil is wholly linked with the secondary coil. Okay, so this means that the rate at which the magnetic flux change with each turn is same for both primary and then secondary coils. Okay, so and then the EMF induced in the primary coil epsilon B. Okay, so the EMF induced in the secondary coil is epsilon S. Here consider that. Okay, so the EMF induced in the primary coil is always equal and opposite to the applied voltage. That is applied voltage we have taken for Vp. That is Vp is equal to epsilon P is equal to minus Np d pi B divided by dt. Okay, So and then the frequency of the alternating magnetic flux in the core is always equal to the applied voltage. இங்க எவ்வளோ voltage apply பண்றோமோ அதுக்கேற்ற மாதிரி தான் இங்க frequency of the magnetic flux in the transformer core. It is also equal for the applied voltage frequency. Okay, so therefore the induced EMF in the secondary coil, it is also same frequency for the applied voltage. இங்க எவ்வளோ voltage apply பண்ணுமோ அதுக்கேற்ற மாதிரி தான் இங்கேயும் அந்த induced EMF ஓட secondary coil ஓட induced EMF also having same frequency. So the EMF induced in the secondary coil we have taken epsilon S is equal to minus ns d pi b divided by dt. Okay, so we already know that NP is the number of turns in the primary coil, NS is number of turns in the secondary coil. Okay, so if the secondary circuit is always equal to Vs, that is Vs is equal to epsilon S is equal to minus ns d pi b divided by dt. So now the first and second equation will be taken the ratio for voltage ratio we have taken secondary to primary. So Vs divided by Vp is equal to the common term will be cancelled. So minus minus also cancel. The remaining term Ns divided by Np is equal to K. K is nothing but transformer ratio. For the ideal transformer, here the ideal transformer, for the ideal transformer, the input power is always equal to output power. We already know that power P is equal to VI. So here the primary Vp Ip is equal to output power for secondary. So Vs Is. So here also we have taken Vs by Vp is equal to Ip by Is. That term also include in this equation. So Vs by Vp is equal to Ns by Np is equal to Ip divided by Is. Ip and Is is that is nothing but current in the primary coil. Is means current in the secondary coil. So the Vs by Vp is equal to Ns by Np is equal to Ip by Is. That is also always equal to K. That is nothing but transformer ratio. So if we see that condition for step-up transformer, so if Ns is greater than Np, that is the transformer ratio value is greater than 1 means here the voltage will be increases, the corresponding current will be decreases. That process is called that step-up transformer. And then here step down transformer, the step down transformer, the transformer ratio value is always less than 1. Here the current value will be increases, the corresponding voltage value will be decreases. Okay, so or otherwise we are say that the step up transformer, the AC low voltage is converted into AC high voltage. That is called that step up transformer. Or otherwise we are say that the step down transformer, we are say that the AC high voltage is converted into AC low voltage. Okay, so and then and then next we are going to see that efficiency of the transformer. So the efficiency of the transformer is defined as it is denoted for the letter is eta. So the eta is always equal to the ratio of output power to input power. It is also denoted for the formula eta is equal to output power by input power into 100%. So we already know that for every machine that is also having some amount of losses will be having. Okay, so the transformer also having some losses will be occurring. So it is not 100% efficiency, but the efficiency range is 96 to 99%. Okay, so because there is no moving part inside on the transformer, all the parts are stationary, அப்படியே ஃபிக்ஸ்டாக தான் இருக்கும். எந்த ஒரு ரொட்டேட்டிங் போர்ஷனும் இதுக்குள்ளே கிடையாது, டிரான்ஸ்ஃபார்மருக்குள்ளே கிடையாது. ஓகே, so next we are going to see that energy losses in the transformer. So the transformer, now only we see that the transformer there is no moving parts like that motors, generator la irukkum mari endha or moving parts கிடையாது. All the one will be fixed, but there is some losses will be occurring. So So the losses in the transformer here, the iron loss, copper loss. The iron loss and copper loss la pathina two type of losses irukku, hysteresis loss and then eddy current loss, and also the flux leakage. First we are going to see that core loss or iron loss. And so here these loss will be taken place in the transformer core. இந்த transformer coreல தான் இந்த மாதிரி losses நடக்கும். மெயினா first வந்து என்ன பார்க்க போறோம்னா hysteresis loss. So hysteresis loss means that is nothing but we are applied some amount of alternating voltage. So again and again the transformer core get magnetized and demagnetized. Repeatedly this process will be happen. So some amount of energy will be lost in the form of heat energy. So these losses is called that hysteresis loss. So these losses will be minimized for using the steel of high silicon content. That should be made up of that transformer core means these losses will be reduces. Next we are see that eddy current loss. So the eddy current loss, that is nothing but the alternating magnetic flux in the core. கோரில் திரும்ப திரும்ப நம்ம அப்ளை பண்ணக்கூடிய அந்த வோல்டேஜினால மேக்னெட்டிக் ஃப்ளக்ஸ் வந்து என்ன ஆகிட்டே இருக்குது, சேஞ்சஸ் ஆகிட்டே இருக்குது. ஸோ மேக்னெட்டிக் ஃப்ளக்ஸ் இந்த காயில்ஸில் மட்டும் இல்லை, இந்த கோர்லையும் இந்த டிரான்ஸ்ஃபார்மர் கோர்லையும் சேர்ந்து தான் அந்த மேக்னெட்டிக் ஃப்ளக்ஸ் வந்து சேஞ்ச் ஆகிட்டே இருக்கிறதுனால எடி கரண்ட் வந்து ப்ரொடியூஸ் ஆகுது. ஸோ எடி கரண்ட்னாலையும் சம் அமௌண்ட் ஆஃப் எனர்ஜி லாசஸ் வந்து ப்ரொடியூஸ் ஆகுது. திஸ் இஸ் ஆல்சோ மினிமைஸ்ட் ஃபார் யூஸிங். Okay, very thin lamination will be used. Very thin lamination will be used in the transformer core. These losses will be reduces. Okay, so next we are going to see that. Next we are going to see that copper loss. Okay, so here we are going to see that copper loss. Okay, so the copper loss it is also occurring for that the coil, the transformer coil occur ஆகக்கூடிய loss தான் என்னன்னா copper loss, because some of the electrical resistance will be occurring if we are applied the alternating voltage, so the current also the alternating current also producing inside on the coil. On that time it is producing some amount of energy loss will be occurring due to in the form of Joule's law of heating, I squared R. You already know that. So these losses will be occurring due to that electrical resistance naala the loss vandu nadakudhu. So this should be minimized for using the thick wire of the transformer windings. In the transformer winding made up பண்றதுக்கு we are using in a thick wire. Okay, so next we are see that flux leakage. So the flux leakage, that is nothing but we are applied the alternating voltage. Here the alternating current will be produces. This current will be changing with respect to time. Time பொறுத்து change ஆகும். So on that time the total magnetic flux in the primary coil is not linked with the secondary coil. So there is some amount of leakage will be occurring. Okay, so this is also minimized by the winding coils one over the other. Okay, ரெண்டு காயிலையும் ஒன்றா வச்சு வைண்ட் அப் பண்ணுறது. ஃபார் எக்ஸாம்பிள் செல் டைப் கோர் டிரான்ஸ்ஃபார்மர் பார்த்தோம் இல்லையா, தட் இஸ் அந்த கோரில் பார்த்தீங்கன்னா டிரான்ஸ்ஃபார்மர் கோரில் ரெண்டு வைண்டிங்குமே ஒன்றா கம்பைன் பண்ணி ஃபார்ம் பண்ணுறது தான் செல் டைப் டிரான்ஸ்ஃபார்மர். ஓகே, ஸோ அந்த மாதிரி பண்ணும்போது இந்த ஃப்ளக்ஸ் லீக்கேஜை வி ஆர் ரெடியூஸ்டு. ஓகே, next we are see that the advantages of AC in the long distance power transmission. So most of the electric power is generated from the electric power station. So with the help of AC generator, so the power station are classified based on the type of fuel is used. That is also thermal power station, nuclear power station, and then hydroelectric power station. So most of the power station is located in the remote area. So the electric power is generated and it is transmitted over the long distance through the transmitting lines to reach the cities or towns where it is consumed. So this process is called that power transmission. So it only having that some difficulties for during the power transmission. So the power will be lost due to that Joule's law of heating. ஸோ ஜூல்ஸ் லா ஆஃப் ஹீட்டிங் படி இங்கே வந்து பவர் வந்து என்ன ஆகலாம், சம் அமௌண்ட் வந்து லாஸ் ஆகலாம். பிகாஸ் த பவர் வில் பி ட்ராவல்டு ஃப்ரம் 100 kilometer டிஸ்டன்ஸ் ஓகே ஸோ அப்போ நெய்வேலியிலேருந்து ஒரு கோயம்புத்தூருக்கு டிரான்ஸ்மிட் பண்ணுறாங்க பவரை அப்படின்னு பார்த்தோம்னா இட் only traveled into that hundreds of kilometer the power will be traveled. இந்த டிரான்ஸ்மிஷன் லைனில் பார்த்தீங்கன்னா 100 கிலோமீட்டர் ட்ராவல் பண்ணும்போது இட் only having that some amount of power loss will be occurring. So it is also reduces for two method. One is the current value will be reduces or the resistance of the transmitting wire, the resistance value of the transmitting line wire value will be reduces. So ஒன்று கரண்டோட வேல்யூவை ரெடியூஸ் பண்ணலாம் அல்லது ஆரோட வேல்யூ அந்த டிரான்ஸ்மிட்டிங் லைனில் இருக்கக்கூடிய ஆர் வேல்யூவை ரெடியூஸ் பண்ணுறது. ஸோ அந்த டிரான்ஸ்மிட்டிங் லைனில் இருக்கக்கூடிய ஆர் வேல்யூவை ரெடியூஸ் பண்ணணுங்கிறது we are making into that thick aluminum wire மேட் பண்ணுறது பார்த்தீங்கன்னா they are using into that large amount of cost will be using. So this is not used for our country. எக்கனாமிக்கலாக பார்த்தோம்னா நம்மளோட கண்ட்ரியில் இது வந்து பாசிபிள் கிடையாது. ஸோ we are using in the second method to reducing the current for using the transformer. We already know that the transformer will be acting as the step up transformer and then step down transformer. அப்போ அந்த பவர் ஸ்டேஷன்லேருந்து ஒரு பர்டிகுலர் டிரான்ஸ்மிஷன் லைன்ஸ் வழியாக கொண்டு போகிறதுக்கு we are using in the step up transformer and then the cities and then அந்த பர்டிகுலர் சப்ஸ்டேஷனுக்கு சென்ட் பண்ணுறதுக்கு வரக்கூடிய அந்த பவரை என்ன பண்ணிக்கலாம் ஸ்டெப் டவுன் டிரான்ஸ்ஃபார்மரை யூஸ் பண்ணி பவரை ரெடியூஸ் பண்ணி ஹவுஸ்க்கு இண்டஸ்ட்ரீஸ்க்கு அண்ட் தென் அக்ரிகல்ச்சர் பர்பஸ் அந்த மாதிரி டிவைஸ்க்கு நம்ம என்ன பண்ண முடியும் சென்ட் பண்ண முடியும். ஓகே ஸோ ஹியர் யூ see that it is another one diagram. Here the power station. ஓகே ஸோ அந்த பவர் ஸ்டேஷன்லேருந்து என்ன பண்ணுறாங்க ஸ்டெப் அப் டிரான்ஸ்ஃபார்மரை யூஸ் பண்ணி they are increasing the voltage, the corresponding current value will be decreases and it is transmitting the transmission lines வழியா அதுக்கப்புறம் அனுப்புகிறாங்க. திரும்ப அங்கே என்ன பண்ணுறாங்க ஒரு பர்டிகுலர் சப்ஸ்டேஷனில் வச்சு அந்த பவரை என்ன பண்ணுறாங்க ஸ்டெப் டவுன் டிரான்ஸ்ஃபார்மரை யூஸ் பண்ணி they are increasing the current value for the corresponding voltage value will be decreases. Then the particular சிட்டிஸ்க்கோ அல்லது பர்டிகுலர் அந்த இண்டஸ்ட்ரீஸ்க்கோ என்ன பண்ணுவாங்க the power will be sent. Okay. And next we are going to see illustration. So an electric power of 2 megawatt is transmitted to the place through the transmission lines of total resistance. Then the resistance R is equal to 40 ohm at two different voltages. So one is lower voltage and then other one is high voltage. Low voltage எவ்வளோ கொடுத்துருக்காங்க 10 kilovolt and the high voltage 100 kilovolt. So let us now calculate and compare the power loss in this two case. First one. So power எவ்வளோ எடுத்திருக்கோம் 2 megawatt, R ஓட value 40 ohm. Okay, so V is equal to 10 kilovolt. So power P is equal to, we already know that formula VI, then I is equal to P divided by V. So P ஓட value 2 into 10 power 6 divided by V ஓட value 10 kilo. So 10 into 10 power 3, that is the current value is 200 ampere. So the power loss, we already know that heat is produced, that is I squared R, that is the 200 squared into 40, then we are getting 1.6 megawatts. The next we are calculate percentage of power loss. So the percentage of power loss 1.6 into 10 power 6 divided by 2 into 10 power 6 into 100%. Okay, so here we are taken into that the percentage of power loss 1.6 into 10 power 6 divided by actual power into 100%. Okay, so here we are getting 80%. Next second case, the power is equal to 2 megawatt R value, but the voltage here we are using 100 kilovolt. Okay, so I is equal to P divided by V. We are substitute, we are getting the current value is 20 ampere. Here you see that 200 ampere. Here we are getting the current value is 20 ampere. So the power loss also reduce. Here 1.6, here 0.016. Okay, if we are calculating the percentage of power loss means we are getting 0.8%. So it is also clear that the electric power transmission only done, we are using the high voltage. It is the loss will be reduces. Okay, thank you.